according to the instructions, they want us to find an equation, then they want us to give the amplitude, period, frequency, phase, displacement, and sinusoidal axis location. I find that interesting because I would have to do B before I could do A. Let's start with B and see what happens. The first thing to do here, as far as I can tell, is to find out where all those different pieces are. So here's the midline right here. We got 3 here, 15 here. The difference between them is 12, so it's 12 spaces from here to here. If we go up 6 and then 6 again, that's 12. So 6 is right in the middle here. So this is 3 plus 6. That makes this 9. So that we have it where the maximum and minimum are. Here's the maximum, and we have the minimum. What do you think the amplitude here is? Yeah, it's 6. It's halfway from the midline to the top, halfway from the midline to the bottom. And so the answer is 6, and that goes here, and it goes over here too. This distance from here to here, from maximum to maximum, is the same as the distance from here to here, minimum to minimum. Or if you want, it's the same from here to here. And this doesn't have as easy a word for it, but it's where the curve crosses the midline on the way down, and then over here on the way down again. It wouldn't be from here to here because they're not the same point in the cycle, right? The cycle goes, I guess, if you want to start here, from here to here to here, and from here to here to here. So those are all the same distance. And in this case, what is that distance? Exactly, it's 180 degrees. Thank you. Let's give this another color so that it's easier to see. There we go. We've got 180 degrees. That's the period. Are we missing anything else? Exactly, the phase shift. And we can do that by looking over here and seeing one of two things, right? We can either look at this and say, you know what, sine graphs start at the midline and go up. Cosine graphs start at the top and go down. So if this is a sine graph, then the starting point shifts from the y-axis to the left by 25 points. If it's a cosine graph, then its starting point over here has shifted to the right 20 degrees. So let's do it both ways, just so that we can see what that looks like. Okay, so we'll have the red be cosine. So we've got y is equal to cosine something. We'll have green be y is equal to sine something. And we'll look over here. If it's the sine curve, where it starts from here, it actually moves to the left by 25 spaces. And if we're talking about cosine, the starting point moves to the right 20 spaces. Okay, so those are the phase shifts. Now, when we do this, and I don't have a theta key here, so I'm going to just use x. We'll talk about the difference between x and theta in a little bit. But for now, I'm just going to put an x in here and say that x, for the cosine, I'm moving it to the right 20 degrees. So that's going to be minus positive 20 degrees. And that number goes in here where it's x minus c. Over here, we're going from here to the left 25 degrees. So that's actually x minus a negative 25 degrees. Okay, so that's how we put in the phase shift. And in terms of the vertical translation, whether it's a sine curve or a cosine curve, it's still up 9, right? The center line goes from here up to here. So it's plus 9. And we'll have the same thing over here, plus 9. So we have put in the phase shift and we've put in the vertical translation. We've got the vertical dilation, which is the amplitude, and we know that that's going to be 6. So that goes here and that goes here. The period is equal to 360 degrees divided by the absolute value of B. And that means if you want to get B, at least the absolute value of it, that's going to be equal to 360 degrees divided by the period. Now we already know what the period is here. The period here is 180 degrees. If we divide 360 by 180 degrees, we're going to get 2. So B needs to be 2. It's on the inside of the argument. The argument is what you call the quantity or the expression that's inside the parentheses in a function. It's the thing that is the input for the function. So we start out with the argument being x, and in this case, we're doing x minus 20, and then we're multiplying that by 2. So all of those things are inside the argument, there and there. And those are the two equations that we get for this. Okay. Is anybody having any trouble with this, or are you following along with this?
Yes.
You mean that this 9 should be over here?
Yeah.
It's addition, so I can do it in any order I like. I think when they put the form in the book, they're probably doing it this way, if this is what you mean. It's the same equation, and you're probably right. I think they do that so that there's no confusion about whether you're adding the 9 inside the argument or outside the argument. I use parentheses to make that clear.
Yeah.
But yeah, you can do this just as easy.
Okay.
Absolutely. The numbers. This number right here is the vertical shift, right? The vertical translation. It is 9 spaces up. How do I know that? Because this is where the midline would be on the parent graph, and it goes up here. This is where the midline went, and that's at 9. So the parent graph has to be moved up 9 spaces to get to here. Okay.
Okay. And also, is the negative 20 the phase shift or the positive 25?
Yeah, the phase shift is either 20 degrees, right, which would be this one here because it's 20 degrees to the right.
Or 25 degrees?
Or 25 degrees to the left. So this would be negative 25 degrees, depending on which equation you're trying to build.
Thank you.
You're welcome. And then finally, right, so you got the two translations. You've got the dilation here. The dilation horizontally is a little more complicated in terms of the numbers. In this case, if you look, you've got 180 degrees from here to here, which means that it's a horizontal dilation by a factor of 1/2. And this number has to be the reciprocal of that. So this is 2. Basically, frequency is just like we use it in English, right? Frequency. How many can you do in how much time? Right? Here's a cycle. How long did it take me? 180 degrees. I can do 1 in 180 degrees. I can do 2 in 360 degrees.